that mistake.
Alrighty, we are now live on YouTube. Welcome to those who are watching from YouTube. We are going to kick off the event in probably just under 30 minutes. Hello to those who are joining us by Zoom as well. I see a Kevin. Hello, Kevin.
Hey there, sorry to join late. I was like running late for a meeting, so that dragged on. You know how it goes.
Yeah, no, it's cool. It's cool. I knew you were not on for a little while anyway. Just, it's cool.
Do the mic check and all that. Everything sound good?
I think everything's looking good. We're now live streaming on YouTube. So we've got a few people. No, like this is kind of my chit chat time. So, so I've got a timer there for people so they know what's happening. Probably going to start it in just under 30 minutes because I want to try this live polling, get some feedback from people. I know what people are doing.
Can people on YouTube hear us as well? Rob was asking a question on Zoom chat. I'm curious as well.
Oh, I'm sorry. What was that? Yes, everything you're saying is being live streamed to YouTube.
Recorded for history. That is really good to know. Thanks, Cheryl.
It's cool. This is a meetup, right? It's not a formal virtual event where we've got 10 people doing AV behind the scenes. Just a chat. Yeah. That's all it is. We're just having a chat. Cozy chat with a couple of hundred people, hopefully.
Yeah, chat with a couple of hundred people and some vendor presentations. It's all good. It's good fun.
It is all good.
I'm going to try and not be extremely vendory. That's generally my approach. So I will do my best.
Likewise, that's my promise.
It's mostly for me. It's you know, I think that there I guess there's a bit where I get to do the little Humio pitch, but I think I'm more interested in the technical content. I hate vendor talks myself, so.
I think as long as there's some, I try and keep talks like 80% just purely educational. I think people are okay if there's a bit of vendor specific stuff in there, like not usually a problem.
Maybe that could be a poll question, Carol. That would be a perfect one.
Say that again, Kevin.
That could be your poll question, or at one of them.
What would be your perfect mix of vendor and non-vendor content?
Yeah. It'd be interesting to see what the community says.
Yeah. Well, you can ask that in your time if you want. I'll check on who's doing the sponsor pitch. So we've got Technovo, Humio, SUSE. Should be someone from X Matters. A couple of other people, I forget. I should probably know these, right? Like, who sponsors my meetup? I should probably know this. Palo Alto Networks and Pusher. Yeah, makes sense. Oops.
Just out of curiosity, Cheryl, are you using OpenEBS to handle all of the streaming stuff, or what are you using?
Just Zoom to YouTube.
Okay.
So this is set up as a YouTube event, and then you pass stream keys and URLs to Zoom.
Yep.
And it should just all work.
Seems to be. So. Streaming is all the rage now, so I'm curious what people use. So.
Yeah, over the last couple of weeks, I've done a lot of virtual talks and tried a few different platforms. And so far, Zoom has been the only one that's just kind of worked.
Otherwise, it just requires a lot of setup and not, it's doing what the people on Twitch do is, it requires a few hours of setup and then a few more hours of tweaking to get everything not jittery. So it's definitely easier just to use Zoom to YouTube for sure.
Yeah, it's been interesting. So I'm going to completely diverge from this because I thought this was kind of interesting. Came up in my Twitter earlier. So these are a bunch of the things that I do outside of these like 3 hours that I actually run this meetup. So previously, like this is just for virtual events. So previously, like most of this stuff I was doing anyway, handling speakers and promoting and setting up the web pages and everything. There was an AV team behind all of this and all of this. And I was handling like the social and the community and this kind of stuff. So suddenly all of that support has vanished. And now we're all doing this kind of, with a mix of 4 or 5 different platforms and tools and trying to stick everything together. Apart from the fact that I'm not selling tickets, that's something. Okay, we'll come back to this. Yeah, that's about right. Hey folks who are joining us on Zoom and on YouTube, we're waiting about 18 more minutes before we kick off. But this is just time to chat and say hello to people. I see Josh.
Hello. How's it going? Kevin, how are you?
Hey, how are you doing, Josh?
I'm doing good, thank you.
I think last time was KubeCon San Diego, right?
Yes, back when we were allowed out of the house.
All right. Well, I'm in Taiwan, so I'm house right now.
You're in Taiwan.
I am, yeah. The, roughly, I think in mid-March when things started to look pretty rough in US, I flew back home here. So I have family and friends here. So.
Oh, that's fair. Nice work.
That's pretty cool. I thought you were in California.
Yeah, it was one of those like sudden, I bought a ticket for like the next day out, and I was like, all right, I need to get out when I can in case they do shut down flights. So it was a very sudden decision. But yeah, I'm usually based out in San Francisco.
Wait, so isn't it middle of the night for you right now? What time is
I
it?
basically have like a flip schedule. It's 1:38 a.m.
Yeah,
Oh,
7 hours
wow.
ahead.
It's got like 4 o'clock. This is what I'm doing for Cheryl, you know, just to attend this meeting.
Kevin,
And Josh, of course.
you're amazing.
No. Yeah, it's ever since I've been back, I've been sleeping at like 4 a.m. to accommodate the headquarter hours because there's still meetings going on that I want to attend. So I do my best to accommodate the coworkers out there.
Still, that's pretty intense. Strange time, like having to keep those kind of times.
Yeah, you get used to it. It's like just like a night shift, basically.
Coming from a very office heavy work culture, it was strange when people started working from home because we're primarily a Danish company. So we're 9 hours from CET here in California, and more people are working longer hours in Denmark, which typically hasn't been the case. And so it's really thrown our company into a loop. And people are realizing, no, I shouldn't work. When you first start working from home, I think you have a tendency to overwork and not leave your desk. So people are just learning all these things in my company these days.
So how are people finding ways to combat that then?
I think that, so I've worked from home for 10, 15 years now. And so I definitely had my methods and things like that. I think that a lot of places seem to overcompensate a little bit. I'm not a big fan of company happy hours over Zoom myself, but I think that there's a lot of people who work in an office that kind of lost that social aspect and we're kind of pining for it. And so it's been interesting. I think we finally, after a month or so of people really, not knowing exactly, how this should work or what they should be doing, I think everyone's kind of found their own groove. But it's hard for us just being spread between 9 hours, just meetings at, 7 a.m., 6 a.m. California time a lot, things like that. So it's a challenge, but I think it's going to last a while. So I think we're all just setting up for the long haul.
So I just joined SNCC like 2 weeks ago. And I have quite a few coworkers in Israel, and it's quite weird seeing them respond on Slack at like 6 p.m., which would be 8 p.m. there. But it seems that most of my Israeli coworkers are just doing like midday to 8 rather than doing like a 9 to 5 or 10 to 6 or whatever.
Yeah, one person on my team has switched to working a later shift and is pairing with one of the other engineers on the team every day. And I got to say that I'm so glad he did it. I mean, it's not optimal for him to be working more like 1 p.m. to 9 p.m., but it's really, we've made a lot of really good progress on our operator because he did that. So I know it can't last forever, but people being willing to adjust can have some good things. And I should ask you some questions about SNCC later. We're actually considering that. So I may hit you up because we're looking at different options around that vein.
Fantastic. Vendor pitch from Josh to start the day.
Yeah, you can just vendor pitch me now. I mean, we have a few minutes, so 13 minutes.
It's, as I said, I've been there 2 weeks, so I won't try and give the pitch yet, but I'm happy to take any questions. And if I don't know the answer, I can pass on to someone who will.
We're just evaluating solutions in that space now. It's kind of different. I've learned, I don't know, at least when you're going through things like SOC compliance, translating the concepts of very old school enterprisey technologies into this cloud native world is actually fairly difficult. Like things like file integrity management aren't things that I really think about in a Kubernetes environment, like using Tripwire. It doesn't make any sense to me, but there's these boxes we need to check on SOC compliancy. So it's been an interesting journey trying to figure out what the SOC people say and what's actually realistic when you run your workloads in Kubernetes.
Yeah, the team I work on actually is responsible for our Kubernetes operator. So we maintain an operator that does live scanning when you update pod resources. So checks config, checks like Docker images, stuff like that in real time.
You almost sold me just with that. So it's moving up my list and priority to check out. All about the Kubernetes operators right now. So
the operator itself is actually open source. So
ours is too. I mean, I don't know if how much y'all know about Humio, but we aren't an open source product, but we are open sourcing our operator. So
yeah, our main product, the SNCC CLI, is also open source, so you can see all that as well. Where we provide, I think, or at least the pitch I've been given since I started working there, is that we provide all of our value in our vulnerability database.
I think this is kind of a pattern that I'm seeing more and more. Like companies are open sourcing as much as they can, like a core closed product, but then open sourcing all the tools around it.
I think that's the tact we've taken. I mean, the operator is one part of that. And then we've built a Terraform provider that can configure your Humio cluster, so configure your parsers, your repositories, your alerts, things like that. And we use that kind of core Go library that we're using for the Terraform operator as also our CLI tool to interact with Humio as well. So I think that it's been good for us, and at least we have a lot of users who are using Kubernetes every day, and just I think they're more, I guess, anxious to use the tools and want the tools to be open source than worrying about Humio being open source or not. As long as they have something that they can, understand and use in their environments that isn't, I mean, it's controlled by us, but they can see it all happen out in the open. It gives them a sense of security using the tools. So it was an interesting choice, because I think there are some companies, I won't name any names, but their operators are proprietary, and so when you install it, you're like, great, this works, and then the time is ticking for 30 days before you have to hand them a lot of money to actually use their product. And that's, I think, especially when you're used to the cloud native world, it's that's a bit tough. And I think having been using Kubernetes for 4 or 5 years and then moving to a company that wasn't open source, that was a hard thing for me to get around to, is where is that line, and how do you walk it? And it seems like sometimes cloud native world can be a little bit disparaging about non-open source things, but I think over the last year I've seen that change a little bit and open up as more big vendors, even if they are open core products, they're still shipping their proprietary stuff on Kubernetes. So is a long discussion in and of itself. That's very political, I assume. So.
I mean, from CNCF's point of view, the vendors are as much a part of this as anybody else, and the closed source nature of that is not it's just another part of the ecosystem, right?
Can I ask a hard question then?
Yeah.
So why? So for like KubeCon, why is there a requirement that the talks be about open source?
I think one is that, okay, so the operational answer is that there are so many vendors and so many talks being submitted that it's easier to make a hard rule and just say no vendor talks than it is to accept some of them and upset other people by which ones are accepted. But I think the philosophical reason is that KubeCon, I think it biases vendors towards providing open source value as well as what their closed source products are doing. Is that fair?
Yeah. I was just curious because I think that I don't know. It seems a little bit the line isn't as clear, I guess, from the outside. I mean, when I sit my talks and they may be about using Humio, but how we're using Humio in Kubernetes and using all of these tools. But I feel that I worry that my talks don't get like they fall down on the list because I am coming from a proprietary vendor talking about these proprietary technologies, and we're not an open core. We're not an open core company. So I think it's easier maybe for folks like Elastic who are our open core to dance that line a little bit easier than me. But I'm just trying to figure out how to frame my talk so I can get it accepted at KubeCon.
That's legit. Find a customer who can talk with you. It's usually a good starting point. And I mean, as I was saying before, my personal theory is that as long as 80% of it or so is educational, I'm not, the thing that you want to avoid, and it's the same with this meetup, is when a company comes in and immediately just spends the whole thing doing a sales pitch. So as long as you avoid that, in my opinion, it's fine. Ironically, the first talk I ever did at KubeCon, which was before I joined CNCF, I did talk about the closed source product that my company StorageOS was building, and that wouldn't be accepted today.
Yeah, it's always hard to know just from the outside. Like when your talk gets rejected, I'm sure there's 10,000 talks submitted to KubeCon, maybe, who knows? And it's a lot. And I'm just I think I've applied like each time, and so I'm just trying to figure out the right combination. So thank you for the tips.
I think there's some good blog posts by people about how to get your talk accepted at KubeCon specifically.
I mean, it's just a difficult thing in general because they receive, I think for San Diego, I know they received something in the area of 2,500 talks, and they can only choose so many. You've got so many reserved for, say you have like 300 and I think it's 340 talks. You've got so many reserved for project maintainers. So, the maintainers of Jaeger and the maintainers of blah, 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 always get their slots. And so that leaves you maybe 250 slots left. So you can choose 10% of the talks that are submitted. And it's all by, it's all a democratic process. Like there's no program committee as such, but it's just a huge amount of people who get randomly assigned talks to review and give it a score.
Yeah, it's having run some regional Ruby conferences back in the day. It's I think it's always hard as being involved in organizing a conference to have to explain to people that it's harder than they think to choose the right talks and choose the interesting talks. And as an organizer, you never always get it right. There's always some where you're just like, wow, that was bad choice. But that's how it works.
One of the suggestions that came up about KubeCon was, I think it's like 12 or 16 simultaneous tracks. And like, how about we make that 30? And it's like, oh my God, as an attendee, I can barely keep on top of so many talks already.
Yeah. Yeah. The key for KubeCon is to not increase the number of talks. It's just like, it's already too difficult to decide which talks to go to. And in most cases, you end up just not going to talks because it's like, there's too much to choose. I'll watch it on YouTube and I'll just talk to people in the aisle.
I'm usually at the booth at KubeCon, so that's usually where I'm stuck most of the time. So I'm glad that they're on YouTube for sure.
It's like Kevin.
I don't know. I think Josh just, visits the booth for swag. I don't know if I think he's avoiding the talks because he wants swag more.
I mean, I do like me some swag, but.
Oh, wait, you're the individual that came by Humio for the owl several times, right, Josh? Is that you?
Not several times, just once.
Okay.
And I do have the Humio owl.
You stopped by in Barcelona, and then you stopped by and you got one in San Diego. I recognize you actually. I have a weird memory. So Hey, Josh. I did not say hi to San Diego, but I think we met in Barcelona, and that was an awkward experience the first time. So
I do like this owl. It's
yeah, it is really good swag. I think the problem for us is, man, those things are expensive. So they used to cost, you know, let's just say $5-6, and now the price is like doubled on those. So that's one of those pieces that was great. I don't know if we'll do it again just because, wow, they're expensive.
In 20 years, I can sell on eBay.
Nice.
Limited edition Humio swag.
We'll see. Maybe we'll be big and famous by then. Well, who knows?
I'm curious about, you know, get people's feedback or insight into how they're kind of doing swag now. Now that all the meetups and conferences are online. I believe GitHub just had a hackathon and they still managed to send out swag. I didn't look into it yet, but I saw some tweets about it. But you know, how are, you know, like Helio or CNCF kind of positioning themselves with swag?
It's under intense discussion right now. Yeah, I don't know what the answer is. I don't know what the decision is, so I don't want to speculate, but I think there'll be some facility for swag somehow.
I mean, so many of the KubeCon shirts I have, my wife loves. Like, she, like, especially the San Diego one, she actually ironed it. She's like, this is a great shirt, you should wear it. And my mom was an Oracle DBA, so at the age of 13 I was wearing HP, and like I was wearing vendor wear at 13. So by my 20s I was like, no, I only wear my friend's stuff now. So I'm not a big swag person, but the KubeCon shirts are always really good.
I mean, I still have DockerCon t-shirts, and it's the thing about wearing t-shirts from conferences that no longer exist.
In Oakland, I used to work at Basho. I don't know if any of you are familiar with Basho. They did React back in the day. And so I did a lot of developer stuff, developer evangelism. So when I left, I ended up having a box of like 200 t-shirts. So I took them to Goodwill. And then, you know, a month later, I see people just walking around in React, you know, shirts. It's actually maybe a good way, not a great place for developers to find your thing, but maybe that would work well in San Francisco.
I had the same experience when I left IBM. I probably had like, maybe not 200, but like a good like 30, 40 shirts I knew I'd never wear again. I kept like one or two that I liked most, and then I donated the rest to Goodwill. But I haven't seen a lot of folks around Emeryville or Oakland wearing IBM shirts, so maybe I needed to donate more.
Alrighty, so I'm going to kick off because we're officially at time. So I'm going to have a few slides, and we're going to do some live polling as well. So if you have your phone or laptop handy, that would be great. You don't need to download anything. It's just a link. So Cloud Native London is a strong, open, diverse developer community around cloud native platform and technologies, usually in London, but today everywhere from Taiwan to California, which is awesome. I'm Cheryl, I run this meetup, and I'm also the Director of Ecosystem at CNCF. So you can follow me on Twitter or Cheryl. We also have the cloudnative_lun Twitter handle tonight. So if you have your phone now, please go to this link, which is a redirect to a live poll. So it will give you this site called polleverywhere.com. You put in your name and then you hit continue. And I'm going to be asking 3 questions about you, and then a couple of questions about how you're using Cloud Native, just so we can all learn a little bit about each other. Okay. So if you lose this link in a moment, then you can still catch up. There'll be just a longer link you can type in. Okay. So first question, is this your first time at Cloud Native London? So you should have yes and no answers. Cool, cool. Looks like the no's are pulling ahead. This is awesome. I think if you're watching on YouTube, then there's a delay of about 10 seconds between Zoom and YouTube. So I'm going to leave this for a little bit longer to make sure everyone has a chance to go to that link, put their name in and start following along. Oh, we're getting back to 50-50, close to 50-50. Cool, it's awesome that 50% of people are new to Cloud Native London. So very, very warm welcome to everybody. Next question. Where are you right now? So you've got the choice of London, the rest of the UK, or everywhere else in the world. I'm guessing that this is Taiwan and this is California. Let's see where people are joining from. Very cool. Actually, quite a few people just joining from around the rest of the UK. Exciting to see people joining from places in Europe, kind of West Coast US, I guess, Mid and West Coast US, and I guess someone in India and Kevin in Taiwan. Very awesome. All right, next question. Okay, so what's your job title? Pick the one that's closest to what you do. So the options are architect, application developer, backend developer, engineering manager, SRE or DevOps, or security engineer, or anything else. I'm curious when people say architect, what they mean by architect. So if you have a more specific title, then feel free to put it in the chat. So let me know, like maybe that's cloud architect or platform architect or something else. Also, probably like 50% I'd say are either architect or SRE DevOps. And I'm also interested to see what other is. So if you want to put what you do in chat as well, then that would be excellent. Okay. I'm going to move on. So tonight we've got 3 talks. So the first will be Stateful in a Stateless Land by Grant from Humio. And Kevin's going to talk about building service meshes with Envoy. And Rob will be, then we'll take a 15-minute break. And Rob will tell us about the open source project that he's working on for cloud native platforms. So I thought I'd ask some questions around some of these topics around storage and service mesh. And I would love if Grant and Kevin and Rob could comment on some of the results as they come in. So let's start with, are you using containers? And if you're using containers, how many are you running in production? So it looks like 50 to 249, pretty much in the lead. No one so far running more than 5,000 containers.
I find this interesting because having worked in a place that did microservices, we used to run a lot. And then at Humio, and I'll talk about this during my talk, like we're really only concerned about running one application, and that really changes the way you look and approach things when you're a product company running a SaaS.
Yeah, I think this will look very different depending on if you're building a product or if you're running it yourself. Cool. I'm going to ask a very similar question next. So if you're running Kubernetes, how many production clusters are you running? Again, feel free to comment. Grant, Kevin, Rob.
That's really interesting to see, because I know there's always that age-old debate versus more smaller clusters versus smaller, larger clusters with varying degrees of isolation and segregation. I think you know, we're going to have some cloud providers on here that are potentially running loads, but you compare these to the CNCF survey last year, and it's a huge change, I think, Cheryl.
A huge change for people running more smaller clusters now? Or
yeah,
which change?
Yeah, in fact, even running them in production in general, right? You know, we look at a year ago from today, and you know, things would have been much more weighted near the top of that of that graph. And I know in our customer base, we're seeing more and more people go in that kind of 10 to 20 range for a kind of mid-sized company. Seems to be where our customers are at.
I think it matters a little bit where you're on the evolutionary path. I think people that started 3 years ago and deployed a lot typically run, you know, much bigger clusters and have problems getting it away because they built all their tooling around the big cluster. So I think it matters where you start in your journey, or where you're at in the journey, I suppose.
Absolutely, but I guess, has the community got a recommendation for people starting new today?
Start with one. I don't know.
Well, of course,
I mean,
right, but you've got to have a
start.
strategy, right, from the outset, so you don't avoid those kind of pitfalls.
I mean, up until a couple of weeks ago, I worked for a company that was doing upwards of 300 million unique users a month, and we were running one production cluster per region. But we didn't, like, it really depends on your developers' needs more so than your users' needs. If your developers are shipping software and have particular requirements around multi-tenancy, if you're running workloads that are highly reliant on multi-tenant features, then running a cluster for each one of those tenants might be better than running one cluster for all your development teams. It really depends on the product that you're building, the developers that you're serving, more so than just the customer base.
Yeah, I'd like to add that I think tooling around managing multiple clusters also improved over the years as people start to have that requirement to kind of break apart the larger clusters into smaller ones. So I think it's like a chicken egg. Did the tooling come first, or the need for, like, you know, smaller clusters but more? But it's definitely improved since.
I think if I remember the results of the survey, the most popular answer was 2 to 5, but there was a spike in the 50 plus range as well. And I guess these could be cloud companies that are running hundreds of clusters, or could be something else. That would be interesting to find out. Just a few more questions to go. Right. All right, let's talk service mesh. So Kevin, I'm particularly looking at you on your thoughts about this one, since you're going to be talking about service mesh later. I think I set this one up so you could choose multiple options. And actually, I was wondering, is there a reason why you'd want to use multiple service meshes? I guess that's a no. see what people are saying in chat.
Yeah, I saw Giles has a question saying that, yeah, it still is the control plane and they use Envoy as a data plane, but the pattern itself, I think, is what they're talking about, like service mesh. I know there's a few companies that use Envoy as a data plane to implement their own mesh because they have their own control plane. So maybe that's why, Cheryl, is that why you concluded Envoy as an option? Yeah, this kind of goes to the poll where most people are evaluating is kind of what we see too as we kind of talk to the community as we build out our own control plane. And I think right now we try to educate the community about what service mesh is and what it can bring to your architecture. It's not really for everyone yet. So I think the result kind of shows, and Istio is the largest by far in terms of community size and feature set. So I'm not surprised by the poll results at all. And hopefully during my talk, I can help the 41% like understand and evaluate other options. Or
Awesome. Any other thoughts? Okay, in that case, I'm going to keep going. Okay, do you run stateful applications with Kubernetes? This is a question that's very close to my heart because the last company that I worked for was building a cloud native storage platform. So it was enabling running databases within Kubernetes. So I'm very interested in this answer.
I am too. I think that this, I know that this number was a lot lower last year. It would probably, be in the maybe 30s or 20s, and then 2 years ago, 3 years ago, it was probably in the teens. It's been something that I've been championing since I was at Vivo, the music video company, and we built some really amazing stateful systems on Kubernetes. And I think with if you take into consideration many things, it's definitely doable, but you'll make mistakes along the way.
Yeah, I'm quite amazed actually that 45% are saying that they're running stateful applications in Kubernetes. That's definitely higher than I've seen before. In fact, might even be the highest number that I've ever seen for asking this question.
Yeah, I'm surprised as well.
Cool. I think this is the last question that I had to ask. So thank you everybody for contributing towards this and answering questions in the poll. Really, really appreciate it. Okay. So back to tonight's event, I'm going to call on a couple of people to say a few words about their company, and I want to thank all of our sponsors. So Technovo, Megan, do you want to start?
Sure. Hi, everyone. I hope you're all well. I'm Megan, and I'm community advocate at Technovo. Technovo is a digital transformation consultancy providing expert partnership and growth without creating dependencies or disrupting culture. Community is truly at the heart of everything we do, which is why we're proud to sponsor Cloud Native London. There are two ways you can find out more about us. You can either DM me on the Cloud Native Slack channel, and my handle is just my name, or you can follow our LinkedIn page where we post our latest updates and blog posts and the like. I also look after one of Technovo's community initiative, Meetup Mates. Meetup Mates is proudly partnered with Cloud Native London. The idea behind the initiative is simple. No one should feel like they can't attend the events they're interested in simply because they have no one to go with. I think that given in the strange times we're in, community is now more important than ever. Our Slack channel is where like-minded devs can come together, discover the latest virtual events happening, and discuss what they've learned. You can find out more info about us on meetup-mates.com, where you can also sign up. Remember, meetups are better with mates. That's all from me.
Awesome, thank you, Megan. Do we have someone from Pusher? Want to say a few words? Okay, I'm going to go to X Matters. Okay, well, in that case, I assume, Grant, you're happy to talk about Humio.
Sure. So hi, and I won't try to repeat my name in my talk a little bit later. My name is Grant. I'm from Humio. I lead the infrastructure team, but because we're a startup, I also do a lot of developer evangelism and reach out and things like that as well. Humio is a log aggregation platform, similar to what people would use a Splunk or use an Elasticsearch for in many cases. The main difference is that we took a very different approach and a fairly modern approach. So our data storage is built by ourselves specifically for logging. And what this opens the door to is this concept of index-free logging. So you're able to send terabytes of data into Humio and still free text search it without the overhead of creating large indexes to find that data. We have a SaaS product, so you can check us out at humio.com. But we also, I think one of the things that makes us different in this area is that we also do on-prem. So many of our customers are sending tens of terabytes of logs to in their own data centers or in their own cloud environment. So I think that really sets us apart in the market in terms of logging, in that we give you the ability to host Humio yourself, because the cost is fairly prohibitive when you're trying to send tens of terabytes a day of logs. And we'll get into a lot of the details about how Humio works and how we use Kubernetes, and I think you'll find it very interesting later. So check us out at humio.com. We have a lot of live workshops over the next month where you can learn more about Humio, or you can try our free trial on our cloud if you'd like to do that as well. It's really easy to get started. We have Elasticsearch compatible interface. Point your Fluent bit to cloud.humio.com, and you're good to go. Thanks.
Awesome, thank you very much. And anyone from SUSE on the line?
Yeah, thanks, Cheryl. So yeah, I'm Rob de Canha-Knight, the CTO Enterprise Cloud Products at SUSE. So who is SUSE? I'm sure many of you have heard of us before. You know, we are the oldest open source enterprise vendor, initially made famous by our SUSE Linux Enterprise Server product, Enterprise Linux, traditionally on-prem, but obviously now fully embraced the cloud as well, both public and private. But in addition to the traditional Linux operating system, we offer a range of software-defined infrastructure products, such as Ceph-based storage. Of course, we provide a Kubernetes distribution, SUSE CAS platform, as well as the first distribution to launch Cloud Foundry on top of Kubernetes as well. So SUSE Cloud Application Platform, our platform as a service offering, both private cloud as well as public cloud and on-prem. Recently made some news because over the last year, we've gone independent. We were previously owned by Micro Focus and Novell before that, but we're now a fully independent company. We've got a fresh new CEO, Melissa DiDamonto, and she's made no secret that she's gonna do her best to propel us to $1 billion company over the next couple of years. So it's a really exciting time to be a part of SUSE, and I recommend everyone goes to SUSE.com to check us out, and SUSE.com/jobs as well, because we are hiring as we expand massively. Thanks.
Very cool, very cool. And last but not least, I think we have Ashley, Palo Alto Networks.
You do have me from Palo Alto Networks. Yes, thank you. Ashley Ward from Prisma Cloud as part of Palo Alto Networks, which is the cloud native security platform. So what does that mean? Well, what we want to do with Prisma Cloud is actually be able to help you do all this lovely cloud native stuff. And as part of that, we want to provide visibility and automation and control across the life cycle of all those things. And in fact, whilst we're not, this was something we all talked about a little bit earlier, whilst we're not an open source project, we do, of course, want to support CNCF, and we do have, for those incubating projects, you know, the ability to make use of our software. So what is that? Well, protecting VMs, containers, serverless functions, right the way through, as I said, from the moment you build something on your laptop, all the way through to something that's running in production. And that does, of course, mean, because cloud native doesn't mean it has to run in a public cloud, but built in a cloud native way. So of course, that's going to work for your on-premise workloads as well. And so, yeah, we really love cloud native, and we're really proud to be a sponsor. And I'll shut up now.
Thank you, Ashley. And thank you to all of our sponsors, without whom we could not run these events. But of course, we also could not run these events without speakers and without attendees. So if you want to get involved, please go to this link. You can sign up. Our next available speaking slots are early next year. You can join our Slack channel and chat to other people. You can check out the videos and the blog posts from previous meetups. And that is the end of this. So I'm going to hand over now to Grant, who is our first speaker. Grant, if you'd like to share your screen, and then over to you.
Great. So I guess I will do the full screen. Are we good?
That's good.
All right. So greetings, everyone. My name is Grant, and today I'm going to be talking about stateful in a stateless land. A little bit of background about my time with Kubernetes. I've been working professionally with Kubernetes for over 4 years. Previous to Humio, I was director of infrastructure at Vivo, the place where the logo you see in the bottom of all your music videos on YouTube. And we did a lot of really interesting things with Kubernetes, from not just using it as the basis for our microservices, but also building stateful applications with it. I did a talk last year at the Kubernetes meetup in San Francisco about what we actually did with that and how it worked. So I'll link to that afterwards a little bit later, as I think it's a pretty interesting talk. But the important thing is that for a long time, I've been a proponent of running stateful applications in Kubernetes because of the power of the platform. And it's really become easier the last few years. And so when I joined Humio, one of the things that I started looking at is how we could take our very traditional deployment and run that in Kubernetes. And there were a certain amount of challenges involved because Humio is a little bit different. So what is Humio? Talked about this a little bit earlier. It is a log aggregation platform. You can send us tens of terabytes of logs and create dashboards and find insights and do very observability type things. It's not going to solve your observability platform problems. No one tool can. Observability is something that is really left to the user, or left to the people implementing it. We can't make your system observable by using Humio, but we can give you the tools to help you get there. So running a stateful service in a stateless land. The challenges, we're going to talk a little bit about the challenges of running stateful systems in the cloud native ecosystem. I'll give a very high level view of Humio's architecture and how it works. I'm not going to go into lots of the magic that goes on under the hood with Humio, but we are going to talk about the important parts of its statefulness and how we're using Kubernetes. And then I'm going to discuss the steps that we went through to make Humio more cloud native, and I think easier to run in these environments. So what do stateful systems look like in Kubernetes today? A lot of people are using stateful sets in particular. And I think this is, for me as a user, has always been fairly confining because we're dealing with persistent volume controllers. I'm running in Amazon or Google, and I have to worry about availability zones. And in some cases, when you're interacting with these systems, because they're fairly new, I've been surprised on some clouds where I have a PV and I have a PVC and everything says it's bound and attached, but I can't actually access that data, or the pod can't mount that container. So these systems are hard. Running a network block storage system is hard. It's a non-trivial thing, and integrating it into these larger environments is hard as well. And I think for the last year or so, we've seen people really pushing into running stateful systems in the way that they're doing that. First was Helm, and now we're in the operator custom resource definition area of things, where vendors like ourselves are writing operators to make running these stateful systems that are hard to run easier. And there are lots of vendors that are happy to help you with this. Like Cheryl worked at StorageOS, there's OpenEBS, there's Portworx, and I having been through many of these demos, it's really neat to be able to be writing to my Postgres and in another Kubernetes cluster halfway around the world, turn up my system and have Postgres over there. That's a really, really powerful abstraction, and I think we need these tools. And I'll discuss a little bit later why we opted not to use these tools actually for our workloads. So why are stateful systems in Kubernetes difficult today? The bugs and inconsistencies with stateful storage and implementations. For a long time, we've been in this place where I'm using Kubernetes, but the storage classes and the way that I run my PVs will differ based on the provider. Some maybe not all the features are always there that you need because Amazon released a new enhancement to EBS or something like that. Network block storage is really expensive because it's a hard thing. So when you're talking about having terabytes and terabytes, hundreds of terabytes of EBS SSD or PDSSD under Google, these costs really, really add up. And in the logging world, the amount that you're able to retain has always been dictated by the amount of storage you have. So if I want to store 30 days or 100 days worth of logs, even under compression, I'm still using terabytes of EBS, and that's quite expensive. most of the applications that are being deployed in Kubernetes that are stateful are databases. So the tools like stateful sets have really been built around this concept of deploying an RDBMS, like a MySQL, like a Postgres, things like that. And so that, I think that there are more stateful systems than just databases, but a lot of primitives we have really been built around databases. And we've really made Kubernetes fit the application, not the other way around, which is what this talk is really about, is how we made Humio fit more how Kubernetes works and less Kubernetes how the databases work. So even WordPress is hard, and just a pro tip, use NFS. This will make your life way easier. I've known a lot of people who have hit the stumbling block, so I thought I've talked about this in previous talks, which is NFS is really great for read-heavy workloads. If your stateful system is read-heavy, look at NFS. EFS and Amazon is a great product. Run your own NFS servers. This will make your life way, way easier. It's way harder to run WordPress in Kubernetes than people think. And so if you've tried to do it, this may help you, but just I wanted to get into an application that wasn't necessarily a database in the stateful system, just to show you kind of those approaches that I've found work for me. So how does Humio work? In a very basic sense, we have these external systems that are creating logs. So you're taking a Fluent bit, or you're taking a file beat, and you're collecting the logs in your Kubernetes cluster, and then you send it to us, and you send it to our first kind of step, which is we parse that data. So is that data JSON? Great, we'll turn that into a structure. If your data is key value, great. If you have a custom log format, we have you can write a parser to put that data into a structured format. From there, we put it onto a Kafka cluster. And this will be key later in terms of how our system actually works. From Kafka, we're reading that data off of a Kafka partition. And then the digest node is actually building what we call segment files or data files. And these are immutable data files. And then finally, after the segment files are all done and complete, we move that on to a storage node. Now, all of the, in general, the Humio cluster is going to be made up of multiple nodes. So we're talking, at least, 3 and generally way more when you're doing a lot more data. So the Humio nodes actually handle all portions of this other than the Kafka portion, or you can break it apart into distinct chunks as well. So this is kind of the data flow of how data gets into Humio. A few more Humio details. It's really built for modern computers, lots of cores and fast disks. I would say most of our on-prem customers, even cloud customers, are leveraging NVMe because it's the best. That's the best experience, and NVMe's aren't as expensive as you think, especially when you compare it against EBS. Humio is highly available. We do use Kafka in a similar way to what most other people use Kafka for. The one difference is that once you read that data from Kafka and write it to disk, or you move it from Kafka. So in general, the Humio installations aren't trying to hold up 10 or 20 terabytes in the air of data like most streaming, like how most people use Kafka for streaming. We have a append-only data structure similar to Cassandra in terms of conceptually. We give a low latency live view of the data. So as the data streams through, you're able to query it. So our average latency, even in the 99th percentile, is less than a second from when we see the data and parse it to when you can actually see it in a dashboard. We took this very streaming processing approach for logs as opposed to a database approach. And this allows us to have the concept of index-free logging. You can free stack search your logs, even if you haven't indexed them. So if I have 10 terabytes of data and I'm looking for this needle in the haystack, just this IP address, we give you the ability to do that because we use a lot of interesting technologies that you've heard about, like Bloom filters under the hood. So why did we want to run Humio in Kubernetes? Well, everyone's doing it. I've been running Kubernetes for 4 years, so if there's a nail, I want to hit it with Kubernetes every time. I'm not saying that's the best choice every time, but that's definitely my inclination. I'm in that camp. The cloud native ecosystem is really appealing. I keep bringing up Fluent. That's one of those parts, but there are lots of other parts of the cloud native ecosystem that when we need them, they're there. So if we opted to use service mesh, we have a lot of interesting choices. If we wanted to use different networking, we could do that as well. It's a very pluggable infrastructure with lots and lots of people, open source and closed source supporting it. This is much easier today than it was 3 years ago. AKS, EKS, and GKE have come a long way. Before, it took a team of several people a year to build the platform to run your Kubernetes. And now that we don't have to do that, we can actually run Kubernetes in a much smaller team. My team's only 2 people right now. So we're able to do this with a smaller team because these things exist. There's lots of powerful building blocks that Kubernetes gives us, such as the integration for load balancers. There's a lot of future flexibility. I think 2 years ago, people were saying Kubernetes is a fad. I think we're past that point now. And the reality is that even folks like VMware are really embracing Kubernetes. And at the end of the day, as someone that sells on-prem software to people running it, we have a customer demand that says, we're moving our workloads to Kubernetes. How can I run my Humio cluster in Kubernetes as opposed to setting it up with Ansible? So some of the challenges that we faced, we used Helm and started using stateful sets initially. So persistent volumes using SSD-backed network block storage, EBS in particular. This was a useful experience, but it felt brittle at the end of the day. The price performance wasn't close to our bare metal installs. The cluster that we had been running our SaaS on and continue to run one of our SaaSes on is far more cost efficient than anything that we were building using SSDs in EBS. It wasn't even close. It was more expensive and it was a lot slower. So we have a lot of different requirements than most Kubernetes environments. The only app that I really need to run or care about is Humio. And we do run other Kubernetes clusters with some services in them, but when we run a Humio cluster, our cloud, our SaaS, we're running one Humio cluster, or we're just running one app, which is Humio, and then the daemon sets like FluentBit and kubeproxy and those things, of course. But really, we're just concerned about one application. So what if we made Humio work to Kubernetes strengths? So what are Humio's strengths in this regard? Well, we have append-only data storage. That really gives us a lot of flexibility versus many other databases, like typically an RDBMS. We had existing data storage management capabilities. So we already had the ability to manage where data is at because we added support for what we call secondary storage. So you can have fast SSDs or fast NVMEs and then a slow RAID or a SAN, and we will move that data as it ages out to the slower disk. So data over 30 days would be on the slower disk. So we already had this thing built into the product. So we use Kafka, which is great. It's useful for us because when we never drop data on the ground. So this gives us the ability to, if we replace an ephemeral node and that node comes up, if it's missing data, it can pull it from Kafka if it needs to. So we have an outside source of data as well in terms of the streams. Like I said, we're running one monolithic application in Kubernetes, which makes it so we're not trying to serve a lot of different masters in a way. We don't have to worry about things like pod affinity and GPU pod affinity for GPU loads and all these things. It's much simpler for us to manage our cluster. And Humio is fairly new. It was originally started in 2016. I think it became, started being sold in 2017, 2018. So we don't have a lot of technical baggage like a lot of other existing systems that are, have 10 years of development around their platform, which makes it hard for them to change. So what problems were we trying to solve? We're trying to decrease storage costs and increase performance in the Kubernetes cluster. We wanted to remove the storage capacity from being the driver of cluster size and ultimately how much data you could keep in the cluster and use. We wanted to remove the tight coupling between Humio and the storage node and remove the constricting use of stateful sets. One of the most hard things to deal with stateful sets is the ordinal nature of things. I set up 5 nodes. I have Humio 1, 2, 3, 4, 5. If I want to remove a node, I can only remove Humio node 5. It's very difficult. I can't go in and pull out Humio node 3 if that's the problem, or that's in the, it's very difficult. It's too constricting. And in the end, it doesn't give you a lot of flexibility to manage these workloads. So how did we get more performance with less cost? We choose to run our Kubernetes workers on NVMe, on machines with NVMe. In particular, yes, we do use Amazon. Google's a little bit more flexible in this area, and if you hadn't heard, you can now load 9 terabytes of NVMe disk you can do 24 times 375 NVMEs on a Google instance, which is great. I was using the cost calculator and saw that, and it really opens the door for some of our customers to store more data efficiently. But the problem with using these NVMe disks is that the storage is now ephemeral. What Kubernetes volume types we're going to use. Should we use the local volume type to do this, or should we use something else? At the end of the day, we had to develop a new thing that we call bucket storage, which stores the segments and cluster data on GCS or S3, essentially using our storage management capabilities. This means that I can have ephemeral nodes, and if I replace a Kubernetes worker, when an instance comes up, it will load that data from S3 or GCS and give you the ability to use that data, like it was a stateful system. So this is a very this is the marketing picture of how all this works. We have the log, goes through Humio, we cache it, and then it interacts with bucket storage. This, I'm going to get a little bit more detailed view later, but conceptually, this is the very basic look of how this works. So some of the benefits that we found of using cloud storage, this really gives us the idea or the ability to have unlimited storage. It's really up to how much we want to pay. And customers are now able to have, instead of 30-day retention, they can have 100-day retention, 200-day retention, depending on what they want to spend and how much they want to spend on their cloud storage. Object lifestyles are super useful in this case because the object lifestyles around these objects, if let's say, my Humio cluster has a problem, or I deleted a bunch of data, I can go restore those objects, tell Humio I've restored those objects, and get those objects back if I have an object lifecycle of keep my deleted data around for 7 days. We particularly use for DR bucket syncing between S3. So we sync our primary S3 bucket to a whole nother region, and we can bring up a Humio cluster that in that other region using that data. So we've taken this very stateful workload, decomposed it, and now we can move it around, which is really powerful for us as an operations team to support these things. If heaven forbid one of the AWS regions does go offline, we do have some amount of recourse. One of the things that we found in our research is that we're not very IOP heavy, unlike a lot of other databases, and so this may differ for some people. But using multi-part gets and deletes, we can move as much data because we're really bound by the network, less so the technologies. So we can move as much data from S3 as we can move from EBS. So for us, the difference really, the difference wasn't that great. And so this means that the cost per terabyte is far cheaper, and as many of you have learned, maybe using S3, in particular, if you do things like use VPC endpoints, then you actually don't pay for the traffic going to and from S3. What's interesting about this is this actually gives us the ability, instead of pulling, one of the things I didn't discuss about Humio is we do have this idea of replication factor. So when I store data, I do keep 2 copies. If I lose a node and a node comes up, it typically would talk to another node and restore that data from the other node. But because we have that data on S3 and the network transfer is free, we don't pay intra-AZ traffic with moving data, restoring data when a partition goes away. So this is a really interesting thing that also added to our cost efficiency, is that there really wasn't any difference in speed, just in cost. So the other thing that we had to do is we had to make the Humio instances ephemeral. This means that we needed to establish, typically when you set up a Humio node, you would give it an ID, and it would use that ID. We had to take that process out. And so now when a Humio node comes up, it talks to the zookeeper that's related to its Kafka and says, what's the next ID available, or what ID should I use? And it will establish that. The difference is that if we do replace these nodes, if we do replace an instance and it comes up, we are actually using the Kubernetes host path. So we're using the local NVMe volume. And if there's already an identity on that volume, the Humio node will go, great, I'll just use that ID, and off we go. So this gives us a lot of flexibility to do things like deployments. We're not removing all of the data. We don't have to restore the data from S3. We can do a deployment and just use the existing data in the host path. This doesn't mean that we don't replace worker nodes at all. It's just something that we don't generally do on a normal deployment. We're not using any PVs or PVCs. We've tried a few different things to not use PV, or to use different like local volume PVs and PVCs and things like that, and just became a little bit tricky, and we found that we didn't even need to use them at the end of the day. And so now when we deploy Humio, using our operator, we don't use stateful sets anymore. That we just use deployments. And I see a lot more people taking this approach. In particular, Banzai Cloud's Kafka operator takes the same approach of moving away from using stateful sets to just a deployment and putting the logic in the operator to manage. In particular, they're managing their EBSs with their operator, but we don't even have to manage PVs and PVCs or EBS or anything like that. So what was the process? Was this even possible? It turns out it was. We had to do a good amount of experimentation, but like I said earlier, we found that using cloud storage was just as efficient as EBS for our workloads. We needed to find the cost versus trade-off sweet spot, so we used a lot of FIO and tested every Amazon instance with NVMEs and found that right mix of CPU, number of NVMEs, et cetera. And then we iterated. We just kept iterating. When we first had this, when we first started working with bucket storage in December, it worked great, and then there were problems, and we just had to iterate through the problems. And several months later, I think we're really confident in this approach and that this approach is going to work for our SaaS customers. So here's the high-level view of actually how it works. So you don't have the VPCs. You can imagine all the other parts and pieces in here. There's some things that I don't have in here, like the private VPCs and things like that. But this is what a deployment looks like of Humio when you're deploying it in this, this stateful way, the stateful system in a stateless way, and it's been really great for our new US cloud and new US SaaS to be able to do this. So what's next for us? Deployments for stateful applications are still an anti-pattern. We made choices, and I'm not sure if they were the right choices. We may regret some things in the future, but we reserve the right to change our minds, and we may, but I don't see us going back to things like stateful sets. This way of deploying just has given us a lot of flexibility. We have a Humio operator that's in its very early stages. It is open source, that handles a lot of this magic and makes running a Humio cluster in Kubernetes fairly easy. We're going to improve the product. This approach opened many doors to how we can handle data differently. So perhaps we'll just turn on query nodes that can query S3 and not use the normal nodes for that. We can decompose the workloads because we have this other source of data besides the local disk. And then we're just going to work on improving our surrounding ecosystem. So we use Nginx ingress controller quite heavily, and we're looking at other things that can benefit how we run the cloud. We hope to improve this over the next year. So how is this useful for you? And I'm sorry, this is not a microservices talk or probably applicable to many of your workloads. If you are running stateful systems, our approach worked because we wrote our application. And so we can make choices with our application to bend it around that. And if you have very disk-heavy workloads that need state, then this talk was really for you. But you may have learned about FIO for testing your the speed of your disk. That's super usable or super useful. And consider ephemeral instances as being a viable solution if you're able to manage having that data somewhere else. Not having to use EBSs, not having to use PVs and PVCs is super. It makes running your cluster much easier. So consider, if you're running stateful workloads, to use ephemeral nodes if you can manage that data. So what can you really do with this? Bring skepticism to the current approaches. I think it's very easy to get excited about Kubernetes and, stateful set. First there was pet sets. Those weren't great. Stateful sets, this is going to solve my workload problems. And it obviously didn't, because people are making Postgres operators that move data around and move the walls around. So we're still not quite there. It's still not easy. It's still hard. You can use this as a reference point for other stateful workloads that you may run. So getting away from kind of the dogma around this is the way we deploy stateful applications. And this talk is really broader, about more than just about Kubernetes. It's about thinking about every application and how it can be more cloud native, especially if you're the person or the company writing that application. Figuring out how your application can run better in Kubernetes easier will make your infrastructure and ops people's lives a lot easier, for sure, than having to run these complex things. So shout outs due to my team, Mike, Justin, and our core engineers, Morten, VP of Engineering, Christian. This all kind of came about in an offsite in Malmö, Sweden. We were trying to figure out these problems, and we started in September and have worked really closely together and iterated together to build what I think is a really impressive platform to run our particular application. So thank you once again. My name is Grant Schofield. You can find me on at Schofield on Twitter. You can email me. We have a community Slack. I'm on the internet. You can find me if you have any questions or want to talk more about running your stateful workloads in Kubernetes. Thank you.
That is awesome. Thank you so much, Grant. Alessio had a question in the Zoom chat. You mentioned Google, Amazon, and Amazon. How about Microsoft Azure? Any experience to share?
I think that yes, and it's mostly from a customer experience. We do have people running in Kubernetes the workloads. I would say that the one challenge that we found in particular, and this is more, I guess this doesn't have to do with this design. We haven't tried this design in Azure, but I found that, PVs and PVCs, you have to make your disk networking, your network block storage choices in Azure fairly deliberate. There's 2 or 3 different things you can do. And I would urge you to do a little bit of research and see what has worked for people. Because the environment that I talked about where things are bound but not working, I did encounter in Azure. I don't have enough experience to say if it's good or bad, but I do know that everywhere is different, and you need to do a bunch of research, especially when we're talking about running these stateful workloads and using persistent volumes and network block storage. It's not something that you just turn on and it works. Every vendor has issues for sure.
Awesome. Does anybody else have questions they want to ask Grant? Or you can put it in the Zoom chat or YouTube chat.
I will pay attention. So if you come up with any during the next talk, I'll be sure and pay attention to the chat, and I'm happy to answer any questions.
Okay, awesome. In that case, I think we should move on to Calvin. Calvin, do you mind sharing your screen?
Yep. Let me go ahead and grab that. Great talk, Grant.
Thank you.
And I'll definitely check out your previous talk in the Kubernetes meetup in San Francisco. Let me share that.
Yeah, I'll share that in the chat. I realize I didn't go to that last slide. So I'll share that last talk in the chat. I think it's on YouTube, so share it now.
Cool. Awesome, then. Let me get started. Cheryl, everything look good on your end for the slides?
Everything looks great. All yours.
Awesome. So hi, folks. Today I'm here to talk about Kuma, but specifically I want to focus on service mesh as a technology or as a pattern for deployments in the future. So a little introduction. My name is Kevin. I'm the developer advocate at Kong. So I'm in charge of all the dev advocacy efforts around all 3 of our open source products, Kong, Kuma, and Insomnia. Today, we're just going to touch on Kuma, but if you're interested in learning more, you can always find me at devadvocado on Twitter, and shoot me a tweet or just DM me if you have any specific questions you want answered. So to set the stage a little, back in 2018, I was at KubeCon in Seattle, and I started hearing a lot of buzz around service mesh. And I was rather new to the whole industry as a recent grad. I was already picking up Kubernetes, like, all right, I got this, and then suddenly I'm like, oh, there's another thing I have to learn. What is this? What are they smoking? It's Seattle State. There must be something that I don't know of. So I kind of dove into it, but back then I think there was a lot of literature online that kind of gave conflicting information, or none of them was very concise and on point. So I kind of just brushed it off until roughly 1 year ago. Our CTO, Marco, came to our team and was like, hey, we need to build our own service mesh. And I was like, oh God, I wish I paid more attention or I dove a little deeper into this so I have a better understanding now. But he was able to give a very kind of great explanation on what service mesh really is and what it means for us. So I'm going to try to kind of reiterate what he shared with me so I can share it with, especially the 45% of people that share on the poll that were unfamiliar with mesh or they were evaluating, just a little more insight on how we perceive service mesh as a pattern. So it all started with kind of a new way of deploying our applications. And that new era of application deployment is moving from centralized to decentralized. And by that, we mean breaking apart the monolithic application, or decoupling, as Calm marketing team really likes to say, decoupling our monolith. And while that gave us a lot of benefits, such as being more agile, it gave us the ability to be more dynamic in our kind of infrastructure. As with the kind of increase of services in our deployments, we saw kind of a loss in control and visibility, right? And that loss was caused by kind of a new variable. Well, let me rephrase. It wasn't a new variable. It was a heavier emphasis on an existing variable, the network. And I want to rephrase. The network was always part of our infrastructure, right? Previously, right, if we had a monolith, the monolith still made network calls to the database. That was always there. But as we move, back to the graph of this, if this was the existing kind of centralized deployment of our centralized infrastructure, and this was our kind of decoupled microservices, there's a lot more network calls happening, right? There's a lot more emphasis on the network. And the problem with that is the network is unreliable. It's insecure. Sometimes it's slow. It adds a lot more kind of unknown, especially to the ops team when they're kind of monitoring all their services. So what we did when we moved from monolithic to microservices, we essentially exchanged the reliability of the CPU, right? Previously, it was just, doing a function call we traded that reliability of the CPU with the unreliability of the network. And that causes issue at scale. So earlier when we were doing the poll, I said that, to figure out if service mesh is right for you, because I don't think it's right for everyone yet, but I think this pattern of exchanging, putting more emphasis on the network will become an issue for folks if they try to deploy more and more microservices. And we'll get into that in a second. So like I said, now we're at a bigger scale, right? Every service needs to kind of interface with another service. And each one of these services or the network now has to handle more, right? Between the services. You have to do encryption, identity management. If you want to do logging, each service now has to kind of provide the capability to do so. And let's say, you want to create a zero trust network and assign identities to each service. When you're scaling to, tens and thousands of services, that becomes harder to accomplish, right? Now you're depending on each service team to build out the capability to kind of to build out the capabilities to maintain all these kind of independent components that the network needs. So previously with a monolith, you only have to implement once, right? The code sits with your monolith and interfaces with a database. That was simple. But now when we take a step back and look at microservices deployment, and let's say we have how many here? 4 by 5, so 20 services. It's already like each service team has to recode that, and each service team might be coding it differently because maybe one service is built in Go, maybe another one is in Rust. So one of the key benefits of having microservices, the ability to be kind of different within services, now comes to bite us in the butt, because now we need a kind of a way to make them interface with each other. We need network management along each one of these services. So this causes kind of the key problem we want to solve, is the fragmentation and poor implementation of network management when we kind of create more and more microservices. We saw this especially, so our core product or core open source project that kind of launched the company was an API gateway. So we already interfaced with a lot of companies that had multiple microservices, but API gateway, the strong suit of it is for implementing like external access to your API, right, outside your network to like other, for like third-party vendors or something like that. But fragmentation and poor implementation of network management was something we saw internally, right, within networks, within your own kind of infrastructure. So what this causes is a lot of issues for your end user, right? This is where kind of, when we talk about like, what is the cost of fragmentation implementation? When you have network issues within your application, the application will not work, right? Especially when you decouple it so heavily. So what can we do about it, right? Like now we have identified the problem. And if our code looks like this, right? If we kind of zoom into each individual service and we say, okay, this is a service, we have the code on the right here that handles all the errors, that retries the security for identity, the logging, the tracing, etc. What can we do with this, right? So the first step is we thought, all right, first, what if we was to separate that from everything, right? We break that apart. This way we can make it portable, right? Because one of the issues was we're re-implementing the same code everywhere, and every team was having issues with the same thing. So we extract it from the main service, make it portable. And then if we were to turn it into an executable, right? This way we can run it along any service, any language, any framework, any environment. So if your service was to sit in a virtual machine, you can still run the same code that handles all the network management without having to recode something. If we were to break this apart and make it into a separate executable, now this component will sit in the execution path of the request to another service. Right? This way it would handle all the request and proxy it to another service. And it would handle all the network management that you usually would have implemented within the service. And I bet a lot of you right now are like, wait, you just said that we are placing too much emphasis on network, like the network. Now you're telling me we want to add an extra hop within our application, right? Now we're jumping from service to the executable to the next service. Give me a second, because it gets worse, right? Or, well, if we kind of zoom into the final picture, it gets worse. If I don't explain, it's that we actually want the same executable on the receiving end, right? This way, the receiving end can also handle the same inbound requests and manage the network that way too. This abstraction of all network functionality from services gives you network management out of the box. So the reason why that extra hop or extra 2 hops is necessary is because it gives you that ability to easily implement network management. But how do we combat that kind of extra hop, right? Because that obviously will introduce some latency. So we want the best way to combat that, right? And that is to run that executable within the same kind of underlying host, virtual machine, or pod. So it has as low as a latency as possible, right? Because if the latency is low enough, and we can weigh, like, this also comes down to if it's worth it for your application. But if it's low enough and the end user does not kind of feel the pain of it, it's worth it because then you don't have to manage as many networks, like management kind of code within each of your service, and you have a central place to manage it all. So if the network request is on localhost, it'll be fast enough, it'll be, latency will be low enough that this might be worth it for you. And then you get the kind of the key functionalities of having one central network management tool. So why build it? Why build it when it exists? So when we were evaluating this deployment strategy, this pattern, we saw that Envoy was a great tool to kind of use as the proxy between the 2 services. It's fast, it runs anywhere, there's a great community behind it, and it does everything we wanted to do for network management, right? So why not use Envoy as your network management layer between your services? And if we zoom out again now and look at our whole ecosystem, all network requests between your services will be routed through the Envoy proxy that sits alongside that service within the same underlying host, pod, or virtual machine. And essentially, what we've described here is service mesh, right? Service mesh is kind of the pattern where all your services are implies that all the services have a data plane proxy running alongside it. So the network management is abstracted from that service and will be built into that proxy, so Envoy itself. And then to manage all those data plane proxies that we have out there, right? We use something called a control plane. So another reason Envoy is a great tool in this pattern, the service mesh pattern, is because it comes shipped with an XDS API, which allows you to kind of easily configure or push configurations to each one of your Envoy proxies. And this way, this control plane can act like a single source of truth for all your network policies across your infrastructure. And when we talk about, there was someone wrote in the comment earlier, isn't Istio the control plane and Envoy the data plane? I want to propose kind of, did I skip a slide there? An alternative to Istio is Kuma, right? Kuma is another type of control plane that utilizes Envoy as a sidecar proxy. So you can easily configure your network policies across your mesh, right? So all your services will have a single source of truth from one control plane. And well, Kuma is going to have a new logo in 0.5, which is coming out next week. So that's why this is up here as well. So I really like the new logo. It's easier to draw, which makes it much easier at conferences on the whiteboards. But a little more about Kuma, right? Kuma was something we open sourced back in September of last year, 2019. It is, it's picking up a lot of kind of speed and a lot of kind of community around it. It's released on Apache 2 license. And it's, we built it with being modern and efficient, because we think that we took the same kind of design principles we did with Kong, and we wanted to apply it to service mesh control planes, right? We felt like existing solutions were either too complex or not universal enough that we felt the inclination to build our own. So it's written in Golang. It has native Envoy integrations because we felt that it was a great proxy to use as a data plane, and it ships with a very clean design. We thought that was probably one of the biggest issue with service mesh right now. It's overly complex, and we wanted a really simple control plane for the end user. And to highlight some things, it's lightweight, extensible. So right now on Kuma is, you can deploy it either on-prem or in Kubernetes. I will give a quick demo on Kubernetes later. But we thought that ability to be kind of extensible and universal is really important because not everyone is running Kubernetes. It ships with already 10 plus policies, so you can easily configure traffic routing or traffic tracing. It gives you the ability to configure via CRD if you're running Kubernetes. There's HTTP API, so you can easily add it to your CI/CD or workflow. And there's a GUI support, so you can easily visualize what's happening in your mesh. Oh, and one very important thing is it's also multi-tenant. So it supports multi-tenancy, allowing each team to kind of deploy mesh at their own speed without having to wait for each other. So we thought that was a really important part of deploying mesh, because mesh is such a new kind of pattern that not every team will be ready to embrace it yet. But we want to give the teams that are ready the ability to go ahead without having to be held up by others. So a quick summary. And we're really kind of happy to announce that Kuma is the first kind of the first Envoy-based service mesh control plane that has open governance. So we have bi-weekly community calls. I think the next one is next week. So I'll send out more information on that on the Slack chat later. But it's also the first Envoy-based control plane to be, in the consideration of being donated to the CNCF. So, we felt that this would be best served if the community was part of it, part of the whole development cycle. And so we thought it would be best if it sat within the CNCF space. So there's actually an issue open on the link there below. I recommend you go check it out, leave your comments, feedback, and thumbs up if you kind of want to see this go through. So we'd love some support on that too. Awesome. So there's been 11 releases since September, so it's really picking up speed. So I'm not going to go through all the releases, but there's one coming up next week. So keep an eye on that. There'll be a lot more kind of functionality in that one too. So without further ado, I have time, right? Cheryl, what time do I have until? Just to
yeah, you've got 14 minutes.
Cool. That's perfect because I personally like to see things in action. So I'm just going to kind of spin up Kuma real quick and show you kind of how easily you can get a service mesh up and running alongside your application. So I built this kind of clumsy marketplace application that has kind of 4 microservices, right? It's fairly traditional where you have a front-end app that consumes a backend API, and the backend API talks to two databases, Postgres and Redis. Each one of them is right now deployed within Kubernetes. Let's see if we do kubectl get pods, look at Kuma demo namespace, you'll see that I have everything up and running. And the reason I have everything deployed is because I didn't want you to wait as pods start to spin up. But to show you exactly what I did, it only took 2 command lines to get Kuma up and running alongside my demo application. So the first was using the Kuma Ctl install command. So you can download Kuma Ctl on kuma.io website. It's just the CLI tool for Kuma. You can use it to install the control plane. That basically just creates the manifest for deploying Kuma on Kubernetes, and I piped that into kubectl apply. So that will create everything necessary for Kuma, all the CRDs, all the deployments necessary, the services. And what that gets you is, if I do kubectl get pods, Kuma system, first is the actual control plane itself. So the control plane will do the management of the policies and then push that configuration to all the Envoy sidecar proxies out there that you have configured to this control plane. But the second part, especially that is exclusive to Kubernetes deployment, is injector. So injector gives you the capability to basically automatically inject a sidecar proxy alongside all your services. So right now, if I do, let's see, if I look at my deployment file, you'll see that the namespace where I've deployed all my services has a label that says sidecar injection enabled. So this will essentially tell Kubernetes that, hey, at least the injector, that I want to have sidecar proxies injected alongside these services. So later when I deployed this application, you'll see that automatically each one of these pods have 2 containers. One would be the actual service itself, and the second one is that Envoy sidecar proxy that would sit in the same underlying host, or in this case, pod. So this way, having it sit within the same pod makes it, gives the application the ability to make the request to a local host, making the latency as low as possible, making sure the overhead of the service mesh is low so you don't feel the effect as the end user. Cool. So I have Kuma up and running alongside my application. What does my application look like? So here's my little whimsical app. Marco wanted it to be a clothing marketplace, so that is what I built for him. And it's very simple, where you can just kind of query, like, if you want more sleeve dresses, right, or sleeve shirts, there you go. You can query items that are stored in Postgres, and then you can read the reviews of each item that is stored in Redis. So the backend API is talking to 2 additional services out there. But the problem is right now, simply because we have all the traffic routed through Kuma, or the sidecar proxies that sit alongside our application, doesn't automatically make our service secure. It doesn't make our network secure because we haven't configured Kuma to do anything yet. Or we haven't configured the proxies to do anything yet. Sorry for misspeaking there. So the strength of service or control planes is the ability to configure these sidecar proxies quickly, so you get those policies in place and get that network management easily set up. So if I was to, if I wanted to add like encrypted MTLS traffic along all these services, I can easily do that because Kuma ships with a built-in CA. You can also use your own CA. It supports third-party CAs, but for simplicity's sake of the demo, I'm just going to use the built-in CA. So if I was to just use kubectl and use a CRD of mesh, all I have to do is add the enable true for the built-in CA. You'll see that the mesh resource is now configured. And I'll just kind of tab back to my application now. There we go. And refreshed, you'll see that immediately the application looks different because now the front end can't even make the request to the product API. Right? That's why it's returning with a 503. And this shows the power of service mesh is the ability to add this configuration among all your services instantly without having to go into each one of your services and implementing the code there, right? The proxy, the Envoy proxy will handle this for you, which is really strong. So while this is only kind of 4 microservices in our marketplace, if we were to scale this up to like hundreds or thousands, this becomes even more powerful. It gives you less kind of overhead for each team. Awesome. So we have mutual TLS enabled, everything is scripted. How do we get everything up and running again? This is where there's a lot of other policies you can add alongside mutual TLS. So the first one we're going to use is traffic permissions. It gives you the ability to dictate who the services can communicate to. So it gives you ability to add security and compliance within your organization because you can specify exactly which source service can talk to which destination service. So here, let's say I wanted all services to be able to talk to each other, right? I'll add a very blanket statement right now. I'll say, for my traffic permission of everything, I want all sources here to match all destination. So you'll see the traffic permission, everything is created. And if I was to refresh this, the application will work again. Great. But this is not very kind of useful in real life scenario. You're never going to add a blanket statement like this because you need that granularity to be kind of to secure the network, right? Not every service wants to talk to each other. If you have a very kind of private kind of service that holds a lot of sensitive information, you want to make sure that only specific services can communicate with it. So let's go ahead and see how we can do that, right? How can we make it more granular? I'm going to go ahead and delete the existing traffic permission. And I'm going to add these 3 traffic permissions. So as you can see, these traffic permissions, instead of specifying like all, right? Instead of using the asterisk to indicate all services, I'm selecting very specific services. I'm saying for a source of front-end service, it can only communicate to destination of backend service. And I also add one for backend to Postgres. So with these traffic permissions in place, if I was to refresh my application, it looks normal again because the backend can still talk to Postgres to query the items. But if you were now to open reviews, let's say reviews was very sensitive for some reason, you don't want people looking at the reviews now no longer work because the backend API no longer has the traffic permissions to communicate with the Redis service to fetch the reviews. And this is where you see the kind of granularity and the strength of having that sidecar proxy come in. I'm going to cut my demo short there. There's a lot more policies you can go through. This is in the GitHub repository of Kuma demo. Everything, Kuma is fully open source right now. We have, nothing is closed source. So you can feel free to check it out, open GitHub issues if you have any questions, and, let us know, open any pull requests if you have, if you want to contribute back as well. We'd love that. Cool. So if we were to kind of summarize what I talked about today, since 4 more minutes, we are kind of in a new era of decentralized applications. And this is where we sacrifice that, the reliability of that CPU, and we get more connectivity over the network. And to solve the issues that we see with more connectivity, we can consider using service mesh as a pattern to kind of simplify the network management. If you want to learn more, you can go to kuma.io that's our official website. or you can check out the GitHubs, right? It's all Kong/Kuma, or Kuma. The Kuma GUI sits in its own repository, and there's also the Kuma website. We also have a Slack channel open to the community, so you can join that as well at chat.kuma.io. And you can always tweet at us to Kuma Mesh. Awesome, and that is it. So thank you for listening. And if you have any questions, you can always reach out to me at DevAdvocado as well. So thanks, folks.
Thank you so much, Kevin. That was awesome. And also thank you for staying up till after 3 a.m. your time to give this talk. So really appreciate it. Does anybody have any questions for Kevin? I'm watching the Zoom and YouTube chat. Okay. I guess not. So what we're going to do now is we're going to take a 15-minute break. So feel free to go away, use the bathroom, take a break, get a coffee, get some water, whatever. And then in 15 minutes, we're going to restart, and Rob is going to join us from SUSE and talk about an open source visual user experience for cloud native platforms. So we'll be back in a moment. In fact, Kevin, there is a question from Laszlo to you, asking how would you compare Kuma to Istio?
One of the most popular one. I was gonna I think I might as well include a slide at the end of all of it now, because I think we get this every time. So there's some key kind of differentials between the two. Let's start with the community perspective. We're open governance. So I think we'll try to kind of be more open with how we kind of operate as a project. We want to donate it as well, so we try to be, vendor agnostic. I think that's something that we've seen. Well, Istio recently announced that they want to donate it too, but that was kind of a big chat over the past year, like whether or not they would donate it. But the second one is kind of from a ease of use perspective. So from my experience with Istio, so I actually have a blog post on how to use Kong Ingress controller with Istio on the Kubernetes blog, which is, if you're interested in adding a gateway to your mesh, that's a great blog to check out. And when I was exploring Istio, I thought there was a lot of complexity to it that kind of made the experience harder than it needed to be. I thought service mesh could be simplified a lot more. So that's a second point that we thought. And third one is kind of deployment strategy. Kuma from day one was built to be platform agnostic. So we saw a need for, especially our enterprise users. They said, we want mesh, but we couldn't only deploy on Kubernetes, right? So we needed a solution that kind of supported both Kubernetes and Universal. So from day one, that's how we built it. Istio now supports it as well, but I think there is also a level of complexity because it's kind of something they added later on. So I think those are kind of the three big kind of differentials. And if you try it out, I'd love to hear your thoughts on it and where we can improve. If you see like certain things you like in Istio more than you like in Kuma, call us out on it. I'd love to hear, and we'll try to improve from there.
Good stuff. I mean, I've got to say, I appreciate that you want to be a good open source citizen and donate it to CNCF. So I am always supportive of that. Yeah, so we're going to take a break, but actually I'll be around. So if anyone wants to chat, I'm here.
How are things looking for KubeCon Barcelona now? Or not Barcelona, Amsterdam, or EU.
Oh, Amsterdam.
Who knows it's going to happen in Amsterdam or not?
Oh, it's definitely not going to be in Amsterdam anymore. Definitely virtual. The Dutch government has said that they're disallowing all large events until September at least. So it's kind of interesting having to do this big pivot to a virtual event. I'm sure everybody's been on a lot of virtual events recently. I joined the Red Hat Summit a few weeks ago. IBM Think was yesterday and today, I think. So yeah, a little bit stressful, but you know, I mean, once this is over, I'm definitely looking forward to getting back to seeing people face to face.
I remember I saw you in Lyon, right? OSS Summit.
Yeah, we met in Lyon.
You were like, I'm so done with traveling. You were like so tired from like just months and months of traveling on end. But now
grass is
it's flipped,
greener,
yeah.
right? Yeah, exactly. It's like, oh, I love travel, but you know, it gets a lot. And then when you're stuck at home, you're like, oh my God, I want to go somewhere.
I did that as well
Grant
last year. I had that last year. Some months I was gone 3 weeks out of 4. And you know, at the end of it, I finally said, you know, look, we have more people now. I don't need to do this. And now, you know, now I kind of pine for it too. I wouldn't want to do it at that rate, but I do miss like going down to San Diego every other month for sure.
I mean, every time I'm looking at your background, Grant, like going, man, that looks really nice.
Yeah, so we live north of San Francisco in Marin, up in the hills, and I think one of the, you know, it's a blessing and a curse, but they've tried to keep Marin, you know, free of people since the 60s, and it's hard to find a place. But when we moved here 4 years ago, we kind of lucked out and found this little gem with, you know, redwoods in the backyard, and our tortoise gets to sit on the deck all day and wander around. I can't find him. I'd pick him up and show you, but he's off getting into trouble on the deck somewhere. So.
Yes, sitting in central London without a garden, I'm very envious of you.
Yeah, I think, yeah, we came from a super urban environment 4 years ago. We lived downtown Oklahoma City. And so we wanted to change, and it's been a nice change. And I think the one downfall of living in Northern California is that you get used to the weather, and now my family doesn't want to leave at all. So.
I just saw in chat Homa saying, I'm sure Cheryl was really wanting to travel. Yeah, it's like, you know, one of the things that I genuinely enjoy is events and tech conferences and talking to a lot of different people, running lots of interesting bits of infrastructure and tech. So I'm definitely missing that right now. Oh, awesome.
So this tortoise is actually internet famous. Like if you search for, I have to tell Kevin's story because he's here, or she actually, we think now. But anyway, if you search for like tortoise strawberry, there's a picture of a tortoise eating a strawberry bigger than the tortoise. And this tortoise had more Instagram followers than anyone I know personally, so.
That's pretty amazing.
Yes. Yeah, it's a lifelong commitment, and we kind of inherited him from our friend who was an influencer, and it's interesting. Tortoises have a lot more personality than people would think.
I just saw a question in the chat for Kevin again. So, if a team deploys Kuma without Kubernetes, wouldn't the network proxy now be a network hop away from each service, leading to more latency? And then what if the network call between the service and the service proxy fails?
Well, so Kuma does, you know, health checks and network like request retries, stuff like that. So the proxy can handle that. But to answer your question on deploying on universal, I think that was kind of a 2-part question, right? I think the first one is deployment question. So you can deploy it kind of locally within kind of the same, so let's say machine. So if you go on like the Kuma demo repository, I actually have like a universal deployment built out as well, where, you know, deploy it across deploy it on Vagrant. And basically it would just, the Envoy proxy executable would just sit within the same machine, and it would just make the request locally there before the Envoy proxy hops across the network. So that's how kind of you would deploy it on universal. And then the second part is, the question regarding, sorry, it's 3 a.m. so I am blanking now.
What if the network call between the service and the service proxy fails?
Oh, between service and service proxy fails. So yeah, so you would have health checks on the proxy itself to make sure that the services are still healthy, and then obviously you would add alerting to that kind of stuff. But I think that's kind of that kind of is up to you how you want to deploy it. But there's a lot of kind of ways around it for sure.
So as at my previous place, we considered, I think it was pretty early on with Linkerd, and Istio was coming out, and it's something that I always had. It seemed like the service discovery that we had was good enough, and what need do you find like customers are trying to solve when they choose a service mesh at the end of the day? Like, because it seems like there's a lot of overhead. Having tracing for free, having TLS is great, and those things make a lot of sense. But what should be the driving factors in choosing to go that route with service mesh, you think?
I think majority of the folks that come to us, especially those bigger enterprise use cases, is security. Having the ability to assign identities to each one of your services, especially as they kind of scale up, is very important. Yeah, tracing and logging are kind of nice to haves, but the ability, and also having that one centralized place for kind of the policies is really important for our compliance. So I'd say that's probably the biggest one. And I really don't think service mesh is for everyone. There is a lot of overhead, and sometimes there is that latency issue that Kelvin brought up. That might not be for your application at all. So it varies for people.
Yeah, I think the big win for tracing always seemed like the big win for me, only because having a place that we adopted distributed tracing pretty early, Zipkin before open census telemetry, and like before Jaeger even, we were doing it. And the hardest part about tracing is getting everyone to use it. And so service mesh seemed like the best way to get everyone, to actually use tracing, because it's great if everyone implements it. If you have 25% of your engineering org that hasn't, then it's not as useful for sure.
Yeah, because then the traces drops off at a ramp, but you're like, wait, like now I don't know where this goes. So yeah, it's kind of a thing you have to have everyone comply to. So that's a good point.
I'm kind of curious if anybody uses tracing. Oh, should I put it this way? Seriously? I see a lot of organizations saying we want to do tracing and we've implemented it, but how useful is it? Like, how many people actually use traces on a daily, weekly, monthly basis?
Our experience was really bad. I'll be upfront. Like, we were like, oh, Zipin is cool, let's implement distributed tracing, and we had a platform of libraries. So we didn't use things like New Relic. We did all that sort of APM stuff internally with the libraries. So everyone using Node had the same HTTP library. They're like, great, we'll add this to the library. They get tracing for free. And so we were spending a good amount of money, tens of thousands of dollars, to store all of this data in Elasticsearch at the end of the day. And then what we found after 3 months is that 2 developers had used it. And so I think that in a lot of cases, operations people think it's really good and developers are going to want it, but I think it really depends on your environment and your engineering group, because we had a lot of consistency between our microservices because everyone used the same apps. We didn't really have these distinctions in our org. Someone's app is failing. Well, if someone's app is failing, it's not, it's definitely not the HTTP libraries. Everyone uses the same one. So for us, the utility was really low, and the cost was really high. And so I honestly don't know if they still use it, but on my way out, I was wondering, if it was useful. In my head, it is really useful. In practice, for me, I'm not sure.
Yeah, I think you make a good point with like everyone, if the application and all the services are pretty consistent, then maybe even like mesh isn't that necessary. Like a lot of, if you could just build one library and implement across all your services, that will work. And then you don't have the overhead of mesh. So
I think we were unique in that when I joined this organization, they were moving from a monolithic .NET app into microservices and Java or Scala or Node. It didn't really matter to me, Python. And so what we did is by having this library, we said everyone has to, if your app is in production, it needs to check these 4 boxes. And the easiest way to check those 4 boxes was to use this library, or else the CTO was going to go after you and you would get, well, I hate to say shamed, but we had a weekly engineering meeting where we talked about whose app is compliant and whose isn't, and people didn't want to be on that list. And so it was a bit of a forcing function, but having that standard made our lives running hundreds of microservices way easier. But that's not the reality for most engineering orgs, and I think we were in a unique case and also had a CTO that was militant about it, and that helped.
Would you say that having that, that checklist made development slower? Because that's the argument for our ability to give developers the freedom to build in whatever formatting,
I guess no, I don't think so, because we didn't have developers making inconsequential choices. So when they had their Node app, they didn't need to worry about what random HTTP library they're going to pull from npm, or make those choices, or just have those inconsistencies. So I think that it was the hard part was actually doing that in a serverless context, which was more of a struggle, and I think it did slow down our serverless development in particular. But I think after, not only were they checking the boxes, but their apps became more reliable. They already had we didn't want to pay for, I'll just say it, we didn't want to pay for New Relic. And so implementing APM ourselves in our app, gave them that power. If you wanted all these things, that APM is giving you, just use the library. And so it was definitely a very carrot and stick approach. And I think, it had ups and downs. And I think that, sometimes we took it too far. Like we had a wall of shame, whose services was the most latent, whose services had the most errors, and everyone saw that every month. And I don't think that's necessarily the way to go about it, but shaming the engineers does work sometimes. But I say this as an infrastructure ops person who also does engineering, but it's definitely a unique balance that we had to strike at the end of the day. And I think it worked really well. And I know other orgs that are trying to do this as well, fairly big orgs that you've heard of that are trying to take this path as well, to really standardize around, if you're using Node, you use one library to do everything, or Python, et cetera. And it makes things slower at first, but I think it speeds up productivity in the long run.
I'm going to interrupt there and hand over to Rob. Rob, are you ready to share your screen?
I am indeed, Cheryl. All right.
Awesome.
Okay.
Stage is yours.
Great. Yes. So yeah, thanks for that. It was actually really interesting listening to that break discussion. I'm here this evening to talk about an open source project that SUSE, the company I work for, started. You can tell the title of the presentation was made by our marketing team, right? I'd have gone with an introduction to Stratos, but the reason that I've decided to do this is I presented at the London meetup, must have been about 4 or 5 months ago now. And we actually had a lot of questions, not about what I was presenting, which was our PaaS, SUSE Cloud Application Platform, but about the UI that I was using. So we figured let's take a little walk through the open source project that is Stratos. So as I mentioned earlier, I'm SUSE CTO of Enterprise Cloud Products. Been at SUSE nearly 4 years now. I started working with Kubernetes a little bit before I joined SUSE, back when, well, things were a lot more challenging in the Kubernetes world, that's for sure. And really trying to guide them on their journey to refine their cloud native products. But by and large, a huge part of my role is helping our customers and partners get on board with cloud native and start their cloud native journey, and help those that are already going along their cloud native journey. I've already done the intro to SUSE pitch earlier on. It's something I quickly wanted to highlight. Like so many other companies, our yearly conference has gone digital. And on the 20th of May, SUSECon Digital is launching at 2 p.m. All the latest updates from our product suite. We've got some great customers and partners coming in to speak. So yeah, head on over to susecon.com. It's free for all attendees this year, both the live streams and all the recorded sessions as well. So I'm going to do, and it shouldn't take longer than 10 minutes of deck, and then jump into a demo about Stratos. Now, SUSE as a company, we launched our cloud application platform back in mid-2018. As I mentioned earlier, we were the first enterprise vendor to run Cloud Foundry natively on top of Kubernetes. And that's an approach which is now being adopted in the wider Cloud Foundry community. I'm sure many of you have come across, heard of, or used Cloud Foundry at some point in your careers. And making it run on top of Kubernetes is really the next evolution in the Cloud Foundry journey. But one thing that we found when we started talking to customers and started getting them involved, a lot of our more traditionalist customers, found that going knee deep into microservices and cloud native can be quite challenging at times. Perhaps they wanted to offer their line of business teams ways to develop and host apps easily on top of their PaaS. And that's a quote we actually had from a few customers, why should our teams have to use a command line tool? And that's largely why we went down the route of developing Stratos. At the time, there wasn't a feature complete web UI for Cloud Foundry. And obviously, as time's gone on and Kubernetes has taken the world by storm, we've adapted that to evolve Stratos into a Kubernetes operator and application management tool as well. Kind of allowing people to get a best of both, whether you're running Cloud Foundry, an opinionated platform, or Kubernetes, for a bit more freedom. A single web UI that can manage both can make life easier for various teams within your organizations. But it's also been received very well by the community as well, and in particular the Cloud Foundry community. It's now been accepted in the Cloud Foundry incubator. So we're hoping to try and push that to be the de facto web UI for Cloud Foundry. I want to highlight it's not actually a product by SUSE. So although it's something that we include in both our Kubernetes distribution and our Cloud Foundry platform as a service distribution, it's not something that customers buy or pay for individually. It's completely free. It's completely open source. I encourage everyone to go and check out the GitHub. So, github.com/SUSE/Stratos. Have a look around and see if it could fit into any of your workflows, really. So what does it really kind of do? It's designed to give an easy way to manage the cloud native platforms, both the platforms themselves, but also the apps running on top of it with a single pane of glass. It doesn't really matter where the Kubernetes or Cloud Foundry installs are running. That can be on AWS, GCP, on-premise. We designed Stratos to be completely cloud and vendor agnostic. It's also worth mentioning that it's skinnable as well. So if perhaps you're running a large number of installations of Kubernetes, perhaps as a service provider, and you want to give an easy way for people to start managing their apps, deploying apps, and doing those kind of initial day two operations, then it might be worth something looking into, especially because it's completely open source and completely free, not open core. The same code on GitHub is the same one that we ship to our customers as well. The main aim of it really is to try and simplify things so that you can empower teams to deploy apps or deploy Helm charts without ever having to touch the CLI. Now, we obviously understand that a lot of developers out there, that's not necessarily going to appeal to them, but something that we've found it's been very well received by a lot of our customers, purely because during the early days, while teams are still learning, and in particular operations teams, some of these new concepts and new patterns can be quite daunting. So providing almost a bridge with a web UI, can help get them onboarded faster as well. And while we're focusing on ops in some ways, we do provide a lot of tools for developers as well, which I'll show you later. And something that's recently appeared in Stratos is tools to help keep the security teams in the world happy as well. Various analysis tools and frameworks that can make things easier. So Stratos itself ships both as a Cloud Foundry native application, if you've already got Cloud Foundry, but also as a native Kubernetes Helm chart, or even as a standalone container that can be spun up as well. It doesn't have any external dependencies, aside from a container engine to actually run Stratos. And it's designed to connect to external Cloud Foundry or Kubernetes clusters. Just before I jump into the demo, I wanted to quickly talk about the SUSE Developer Sandbox. This is something that we've launched this month, and it's effectively a cloud environment that runs SUSE Cloud Application Platform and allows you to create an account and gives you, a bit of memory, a bit of disk, where you can try out SUSE Cloud Application Platform for free. So, if you are investigating microservices, as I'm sure many of you already are using them, but perhaps some of your customers are, they can just go up and have a little play and start seeing if the Cloud Foundry API can be of any use for them. So I'm going to do a demo now, and there is a kind of a side note there that I'm actually going to be demoing alpha code. I'm going to be a bit brave tonight, so to be a bit interesting to take us all on this journey, and do fire off questions at any time. So, as I mentioned earlier, although this is currently themed with the SUSE branding, it is customizable, skinnable. Just fork the repository and change it as you need. I'm just going to log in as a local admin user for starters, but I should mention we've got full kind of SSO and LDAP capabilities out of the top. I'm going to basically take a walkthrough of the UI and show some of the base features available. So on our home screen, I've not identified any apps or clusters that are my favorites at the moment. So there's nothing there. And where I mentioned earlier, we cover both Cloud Foundry and Kubernetes. There's almost two kind of parts to Stratos. There's the part that deals with managing Cloud Foundry instances and the part that deals with managing Kubernetes clusters and the apps that are on both. And obviously where the APIs provided by Cloud Foundry and Kubernetes are very different, that's why we've kind of separated them into two. But we find that having kind of one tool that allows people to manage their Cloud Foundry environments and their Kubernetes ones can make things a little bit easier. I'm going to walk through some of the other areas in a bit, but I want to quickly head down to the Endpoints tab. So as I mentioned, we can connect to multiple Kubernetes Cloud Foundry instances. We can also connect to and mirror various Helm chart repositories, in fact, any Helm chart repo that you want to mirror. So whether that's a custom one that you've got on-prem or one of the upstream public ones, because as I'll show you later on, we're going to connect to an existing Kubernetes cluster and then deploy some of the applications through there. At the moment, I've got this one just connected to a Kubernetes running or EKS instance that's up and running. I've also got it connected to a Cloud Foundry instance that is actually SUSE Cloud Application Platform running on top of that EKS cluster. And I also got it connected to a second Cloud Foundry instance, that developer sandbox that I mentioned earlier on today. It's also worth mentioning we can connect Stratos to Prometheus to embed metrics from our running apps inside our single pane of glass. If I head over to the Applications tab, what this is currently showing us is a combined view of all of the apps running in all of the Cloud Foundry clusters that we've got connected to Stratos. As I can see here, there's my one running in the developer sandbox. one running in my EKS instance of Cloud Foundry as well. And I can go on there and see various bits of information about my app. I can restage the application, I can restart it, view the revision history, etc. If I wanted to scale up the number of instances, that's quite easy to do as well. But something that's also quite handy is setting up the Cloud Foundry auto scale policies as well, which we can do in here. Now, we found that some ops teams have found that much easier to use than going through the CLI to achieve the same thing. We can also pull out all of the log stream from our apps and view and manage routes for our apps, as well as, of course, the complete audit history for everything that's happened with that Cloud Foundry application. Now, just before I move on to talking about the Kubernetes side of things, just wanted to touch on the marketplace as well. Now, for anyone unfamiliar with Cloud Foundry, this is a marketplace of backend services that we can provision and then easily connect to our application. And these are just some sample ones that we've got deployed here. So the majority of core Cloud Foundry APIs can be managed through Stratos. And I think it's important to mention it's not just SUSE's Cloud Foundry that you can connect using Stratos. You could connect to the SAP Cloud, IBM's Cloud Foundry, Pivotal's Cloud Foundry, because it's just using the standard API interfaces. I'm going to go back down to the Kubernetes tab. So this is where we've got any Kubernetes clusters that we might have deployed. As I mentioned, I've already connected it to one that I deployed in EKS earlier. It's worth mentioning we're looking into adding the provisioning and management of the clusters themselves to Stratos as well. And by all means, we more than welcome some PRs and some assistance in that area as well. But if I go to workloads, so these are workloads, these are Helm charts that have been deployed to that EKS cluster that I mentioned earlier. I deployed them just before joining the Zoom call earlier today. If I just choose one, say Airflow, I can kind of get a good overview of all of the components of that Helm chart. So 7 containers, 7 pods, 2 config maps. We can see the output that would have been produced if you were running a Helm install on the CLI. That's sometimes handy, when it disappears off the screen, we can access that anytime. We can also view the config values that were supplied when deploying the Helm chart. And if I'd have specified anything differently when deploying the Helm chart, I'd be able to see those there as well. But something else that's quite cool, I can see all the resources deployed with the Helm chart. So, for example, the containers that were deployed. And if I click one of the pods there, it's now bringing up a more raw API browser for that specific resource. So that works with both pods, services, config maps, any component really that was deployed with that Helm chart. So if we need to take a deeper look, that's quite easy for us to do there. And obviously I can view any associated metrics related to that Helm chart as well, because we connected it to our Prometheus instance, which I think is pretty cool. If I go back into it, final thing I want to show for that existing workload is the resource overview. So we can get a visual map of all of the resources that were deployed as part of that specific Helm chart. As I mentioned earlier, it is alpha code, so things aren't quite where they should be, but you can get a good overview of it there. We can see all the containers, in this case, a few stateful sets that were deployed as well, and a couple of PVs as well. So as I mentioned, we can connect it easily to pretty much any Kubernetes cluster. We can do that by simply clicking the plus at the top. Depending on the type of cluster that's deployed, it's a slightly different workflow if we're using GKE or EKS, for example, because we're offering native IAM integration. So rather than providing just a kubeconfig file, we'd support natively that, as well as SUSE's own Kubernetes distribution, SUSE CAS platform as well. I'm going to choose the generic Kubernetes option, because earlier on I also deployed a cluster on Amazon. I did cheat a little bit. I actually used Rancher provisioning engine to deploy that, but I really wanted to do that to highlight how vendor agnostic this really is. I've not actually really shown anything that's part of SUSE or any SUSE product aside from our open source Stratosphere, because this is obviously one of the Rancher exposed endpoints, which I can register. I can either choose client certificate authentication, or if I've already got a kubeconfig file, I can choose that there. So it's your standard kubeconfig that I'm deploying there. Now, this is quite handy because the platform operator will effectively connect the initial cluster, but individual users will go on and register their own credentials. So we're not doing a kind of a Helm 2 approach of deploying Tiller and then, granting root for everyone to the cluster. We're able to give fine-grained access control to each individual user. They'd have exactly the same rights as if they were using kubectl on the command line. And then we can connect up and we can see our clusters immediately available there. And if I drill in, we can see all of the available pods and anything that's already been identified on the cluster. Now, a lot of people still use the Kubernetes dashboard. It's understandable. It's a good little handy tool. Rather than kind of replicating stuff that's already out there, we just provide the ability to connect Stratos to an existing Kubernetes dashboard. Now, AKS obviously deploys the dashboard by default, so we can just create the service account and then a very simple iframe to view the dashboard. So it's not necessarily duplicating everything, just providing an easier way to go and view the dashboard for the stuff that you might not be able to do yet with Stratos. If I go back into my cluster, as I mentioned earlier, we've got some tools here now which might make life easier for the security teams. Stratos is completely pluggable, completely extensible as well. One of the most recent things that we've added is the ability to run various analysis tools on top of any Kubernetes cluster. Out of the box, we've got Popeye, KubeScore, and Claire as well. Tools I'm sure many of you who have run clusters for a while are familiar with. But what perhaps isn't yet present is a single way to run and view all of those across any of our clusters. And I can go in and schedule a run of Popeye, KubeScore, and Claire. And when those are reported completed, my Zoom window's just over the way, so I can see Popeye's done already. I can go in there and view the report of all of the resources. Obviously, in this case, it's advising me on Kubernetes best practice. So as a cluster operator who perhaps isn't, experienced with Kubernetes, relatively early in their journey, I can go in and have a look and see perhaps what best practices my devs need to work on a little bit. Or if I care more about the vulnerability side of things, I can go in and bring up one of my Claire analysis reports as well. Have a click through there. Now, obviously, Claire being an upstream open source project, there's a few other analysis tools which would be fairly easy to integrate into Stratos as well. It's just a basic, engine that allows you to invoke and then display the reports. It's all about bringing information from the various sources into one central place. And there's not a lot of tools out there yet that do that, at least not in a graphical way that can be easier for teams to get on board with. Now, if I go back to my workloads tab, I can already see some Helm charts that were deployed on the AKS cluster. So it's not necessarily things that are deployed through Stratos. Whether someone's deployed it on the CLI or they've used Stratos, it'll show up here. And additionally, the analysis results from the analysis tools that were run are also available to be overlaid on top of our workloads as well. So if I choose Redis, for example, just tell it to run those analysis tools and refresh my page with a bit of luck. There we go. I can easily see, graphically, there's 9 warnings against my my Redis pods that are running there. So in terms of deploying an application, this is why we've largely got the Helm section here. As I mentioned earlier, we can add in any upstream or local Helm chart repository that you've got. We can view them in a list, and let's go for Redis, for example. Choose the one from the Bitnami chart repository. I can view the README for that specific chart. I can then go to install that chart, choose which cluster I want to install it into. Obviously, any of the ones that I've got rights into. Choose what namespace I want to install it into. In this case, let's just go for default, create it if it doesn't already exist. Any values that I need to customize, I can type them in or copy from the vendor provided config values YAML. And then click install. And then all the information is available there. And just like before, I can go in, browse my resources, and bring up the API browser. So what we found many of our customers doing is using this to enable other departments to get the value of Kubernetes more than anything else. If we can just provide basic documentation, you can then have, say, your marketing or your line of business teams deploy apps into a cluster without ever touching a CLI, without ever really understanding what Linux is. Because once they've deployed, they can go in, click it, and easily view the URL that service is going to be available at. And as I mentioned, that's kind of one of the main initial aims of Stratos. And that's why it's received quite good feedback so far. So that's my kind of quick 10-15 minute walkthrough of Stratos. There is a lot more out there, obviously, but this is, a quick run through. But I recommend everyone go and check out the GitHub repo and perhaps see how, your teams might make use of this, or your customers might want to make use of this. And as I say, we always welcome PRs as well. So with that, I think that's everything from me. I see Zoom's got a couple of things popped up. So see if there was any questions. Cheryl, was there any questions?
I think there was a remark about your logo.
Oh yeah. So yeah, this is part, one of SUSE's employee networks. We've launched a Pride at SUSE network, of which I'm a founding member for our LGBTQI+ employees, which has been really good fun for it. Yeah, thanks, Scott. So yeah, if there's any other questions, just type them in. I'll be here for. Oh, yeah.
Oh, I had one. I'll just ask it because I don't want to type. So, this is, I guess, I haven't really used a lot of, UIs for Kubernetes for a long time. So this was super interesting for me to see. And I don't have a lot of Cloud Foundry experience. It's the one thing that I'm curious about is I see a lot more people building operators that have CRDs. What's the future of supporting CRDs in Stratos?
Yeah, it's very high on our roadmap. The kind of history of that for us is as we've migrated more and more Cloud Foundry on top of Kubernetes, we are moving from deploying Cloud Foundry with Helm chart to using the upstream CF operator to operate and manage Cloud Foundry, and moving from traditional Helm-backed marketplace services to using operator-based services. And as part of that, we will then be bringing CRD, Insight, and management into Stratos. It's one of the main reasons we've got the Kubernetes dashboard integration, because it was a top requested thing for our customers, just being able to view the CRDs and the status. And that's why it's quite high up on our priority list to get that in there.
Great, that's good to know. This is definitely something I think our customers could look at, especially those that aren't as familiar with Kubernetes, which is becoming more and more the case, it seems.
And that's exactly what we're seeing as well. As we start approaching a lot of these legacy companies that want to modernize, tools like Stratos can help them along their way in getting started.
It's a great talk. Thank you.
Thanks, Grant. Cool. Any other questions from anyone? Great. So yeah, thank you, Cheryl. It's good to be here again. Can't wait to see you all in person next time.
Let's hope so. Thank you so much, Rob. I really appreciate you coming virtually to come and speak here. So we are pretty much out of time for tonight. I want to thank everybody for joining and sticking it out, even if we can't be together in the same place. And I want to remind you that if you want to get involved, then go to this URL. There's links there for coming to speak, for catching up on previous meetups. Just let me know. Other than that, have an excellent evening or afternoon or morning, depending on where you are. Take care. I'll see you again in the first Wednesday of June. Bye.